Assalamualaikum and a very good day to everyone watching. In this video, we will be presenting about our research on analysis of vitamin C content in packed fruit juice using Redox Titration method. Before we move further, I would love to introduce our group members. This is our group members. First, we have me, myself, ALIA, ATTHIRA, WARDAH, SYAFIQAH and NATASYA. Now let's move on with our topic. First, I will explain to you about titration. Titration is a common laboratory method of quantitative chemical analysis to determine the concentration of an identified analyte by adding a known amount of another substance, which is titrant. Titrant prepared as a standard solution of known concentration and volume. Titrant is gradually added to the sample from a burette until the equivalent point is reached, where titrant and analyte are in equivalent amount. What about redox titration? It is a laboratory method used to determine the concentration of the given analyte by causing a redox titration between the titrant and analyte. It is based on oxidation-reduction reaction between the titrant and analyte. For oxidation reaction, analyte will lose electron to an oxidizing agent, while for reduction reaction, titrant will gain electron from reducing agent. So, what is our research focusing on? The experiment in our research is focusing on determining the analyte content in ascorbic acid in the sample which packed fruit juice from different brands. What about redox titration? How does it relate with our research? So, in the experiment, analyte that being used was ascorbic acid or also known as vitamin C. In order to detect the content of vitamin C in the juice, redox titration was done. Redox titration in this experiment is known as iodometric back titration. Vitamin C is the analyte which acts as reducing agent that undergo oxidation reaction. Iodine acts as an oxidizing agent which undergo reduction. It first titrates with vitamin C, then the excess iodine back titrate with sodium thiosulfate. Sodium thiosulfate is the titrant which acts as oxidizing agent that undergo reduction reaction.
Next, I'm going to talk about the theory. Vitamin C, ascorbic acid, is an essential vitamin needed for normal body functions and good health. Humans cannot produce vitamin C naturally because of a genetic mutation, so it must be obtained from food. Next, vitamin C helps to produce collagen for healthy skin, bones and tissue. It is also support wound healings and tissue repair. Vitamin C acts as an antioxidant, protecting cells from damage. It also helps to strengthen the immune system and lower the risk of certain diseases, including heart disease and cancer. Good sources of vitamin C include citrus fruits such as orange, lemon, lime, fruit juice, fresh fruits, and vegetables. A lack of vitamin C can cause scurvy, a disease characterized by bleeding gums, weakness and fatigue, and poor wound healing. Since vitamin C is important for maintaining health, determining the vitamin C content in food helps us understand their nutritional value and choose healthier diet.
Assalamualaikum. My name is WARDAH and today I will talk about methodology. Method for vitamin C that we use is redox titration method. Fruit juice samples were prepared under acidic conditions. Potassium iodide generate iodine in situ. Vitamin C reacted with iodine through a redox reaction. Excess iodine was back titrated using standardized sodium thiosulfate solution with touch as the indicator. The vitamin C concentration was calculated from the amount of iodine consumed during the reaction. For the procedure, first you need to prepare the fruit juice sample and acidify the solution using dilute sulfuric acid. Then add potassium iodide, KiO3, and potassium iodide to generate iodine in the solution. Vitamin C reacts with the generated iodine until all the vitamin C is consumed. The excess iodine is back titrated with standardized sodium thiosulfate. Number 5. Starch indicator is added near the endpoint, producing a blue-black color. Continue titration until the blue-black color disappears, indicating the endpoint. Last but not least, calculate the vitamin C concentration from the amount of iodine that reacted. There are 4 advantages that we can learn from the experiment, which is simple and easy to perform, low-cost laboratory technique, provides reasonably accurate result. Lastly, suitable for routine analysis of food and beverage supplies.
The vitamin C content in packed fruit juices was determined using the Redox Titration method. In this method, vitamin C reacted with iodine and the excess iodine was titrated with sodium thiosulfate solution. The amount of vitamin C present was calculated from the differences between the amount of iodine added and the amount of iodine remaining after the reaction. The results showed that the measured vitamin C content was generally slightly lower than the value stated on the product label. For example, Raihan orange juice was labeled to contain 35 mg per 100 ml of vitamin C, but the experimental result was 32.45 mg per 100 ml. Similarly, Raihan pineapple juice was labeled as 30 mg per 100 ml, while the measured value was 26.88 mg per 100 ml. This difference may be due to the instability of vitamin C, which can be degraded by exposure to heat, light, oxygen, and long storage periods. Despite these differences, the measured values were close to the labeled values, indicating that the fruit juices still contain significant amount of vitamin C and were of acceptably quality. Table 1 compares the experimental determined vitamin C concentration obtained using the Redox Titration method with the vitamin C values printed on the product labels. The measured values were slightly lower than the labeled values for all juice samples. As for figure 3, clearly shows that the calculated vitamin C concentrations are consistently lower than the labeled concentration. This difference is expected because vitamin C is unstable and gradually degrades during storage, transportation, and exposure to the oxygen, heat, and light. However, the differences were relatively small, indicating that the Raihan juices still retained most of their vitamin C content. As for the graph, demonstrate that the experimental values closely follow the labeled values. Although every calculated value is slightly lower, orange juice showed that the highest vitamin C content among the Raihan products, while mango and apple juice contain the lowest amounts. This indicates that citrus juices naturally contain more vitamin C than non-citrus juices.
Next, I'm going to talk about the applications of redox titration in food. Titration is an analytical technique that is widely used in the food industry. It allows food manufacturers to determine the quantity of a reactant in a sample. It can be used to discover the amount of salt or sugar in product or the concentration of vitamin C or E, which has an effect on product color. For example, determination of salt in cheese and butter, reaction of salt in food with standard solution of silver nitrate, AgNO3 plus NaCl produce AgCl plus NaNO3. Next, unreacted AgNO3 is titrated with potassium thiocyanate using Fe3 plus as an indicator. AgNO3 plus KCNS produce AgCNS plus KNO3. The endpoint reacts with Fe3 plus to produce reddish brown precipitate when all salt is reacted.
In conclusion, the vitamin C content in packed fruit juice was successfully determined using redox titration method. The experiment showed the application of iodometric back titration in analyzing ascorbic acid concentration in different fruit juice samples. Vitamin C acted as a reducing agent and reacted with iodine generated in the experiment. By measuring the amount of iodine consumed, the concentration of vitamin C in the juice can be calculated. Redox titration is an effective and reliable method for determining vitamin C content and evaluating the nutritional value of commercial fruit juices. This experiment also highlights the importance of vitamin C in maintaining good health. That is all from our group. Thank you for your time.